Hey there everybody, I hope you're doing well and I welcome you back to another video. Today I'm going to be teaching you all how you can find the limiting reactant of different chemical equations. So let's say we're doing a combustion reaction with glucose. Okay, and we want to find what the limiting reactant in this is. Glucose, of course, is represented as C6H12O6. And let's just say for this problem, we have 25 grams of glucose. And since all combustion reactions are essentially just reacting something with oxygen, we need to know what mass of oxygen we're going to be reacting this with. So I'm going to say it's 40 grams. So we need to create a chemical equation that's balanced in order to solve this, to find the limiting reactant. So the balanced chemical equation would look something like this: C6H12O6, and then we're adding this with oxygen, and this is going to produce some water and some carbon dioxide plus some energy as an output, but I'm not going to include that. Okay, and we need to check if this is balanced. If it's not already balanced, then we would have to balance it. Okay, so let's just do a quick tally. For the carbons, we have 6 on this side, and then for the hydrogens, we have 12, and 6 plus 2 is 8. And then on this side, for the carbons, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. So it's not balanced. We need to balance it. One very easy way we can balance the carbons is by multiplying this by 6. When we do that, this becomes 6 on the carbon count. This becomes 12. 12 plus 1 is 13. So now we have 13 oxygens. Let's try and match up the hydrogens here. So now the hydrogens are 12. The oxygens are 6 plus 12. That's 18. So you have 18 here. It doesn't match. These two need to be made to match. The others match. So you can just multiply this by 6. So now that's 12 plus 6. This is 18. Now your equation is balanced, which means we can start solving for the chemical, like the limiting reactant. Okay. So to get the limiting reactant, we have to use this formula. N is equal to mass over molar mass. We need the moles first of this and of this. So we have the mass, we need to find the molar mass. So in the case of glucose, the mass is 25 grams over C6, that's 12 times 6, and H12, we'll just say it's 12, and O6, that's 16 times 6, so let's quickly calculate. 12 times 6 first, plus 12 for the hydrogens, and then plus 6 times 16 for the oxygens, 180. So that's the molar mass of glucose, 180 grams per mole. And this is equal to 0.139 moles. We need to do the same thing, of course, for oxygen. I should probably specify here that we're talking about glucose. Okay, so for oxygen, we have 40 on top, and at the bottom, the molar mass of oxygen is just 2 times 16, which is 32. This is 5 over 4, so that would be 1.25 moles. Now we also need to consider the ratios over here. So you need 1 of these and 6 of those to create a full reaction. So considering that ratio, you would have to divide this number by 1, and you would have to divide this number by 6. If you divide this by 1, it's the same number. If you divide that by 6, it's a different number. So let's just do that real quick. 1.25 divided by 6, and it should be somewhere around 0.2. 1.25 divided by 6, 0.208. So the smaller number between these two is the number that is the limiting reactant. And in this case, that's glucose. So glucose is the limiting reactant. Glucose is the limiting reactant. And now, if we want to know how much excess there is, if we want to find out how much more of this there is than the amount of glucose, we can just do 0.208 subtracted by 0.139 and multiply this number by 6 because the ratio is 1 to 6. 0.208 subtracted by 0.139 times 6 is 0.414. 0.414 moles of oxygen gas in excess. And that's pretty much it. I hope this video was informative, and thank you guys for watching.